This is lesson 3.7. We're doing implicit differentiation, and we have an equation of x squared times y squared equals 9, and they give us the point -1, 3, and they want us to find the equations of the tangent line to this curve at this point, and also the normal line to this curve at this point. So the first thing we need to do is to find our derivative, and instead of solving for y and having an equation that's explicitly determined in terms of x, solve for y in other words, we're just going to go ahead and use implicit differentiation and find the derivative of this equation. So we have multiplication between the x squared and the y squared, so we're going to have to use the product rule. So we're going to take our first expression, which is x squared, times the derivative of y squared, which would be 2y, times dy over dx, plus our second expression, which is y squared, times the derivative of x squared, which would be 2x times the derivative of x, which would be dx over dx. But remember, dx over dx is just equal to 1, so we can leave that off. Equals the derivative of 9, which would be 0. So there's our derivative. Now, we really have two options. We could solve for dy dx right now, and then plug in our numbers, or we could plug in our numbers first. We could plug in -1 for x and 3 for y, then solve for dy over dx. So either way will work. I think what I'm going to do on this problem is solve for dy over dx first. So this is one term, because all of these expressions are being multiplied together. This is another term. So I'm going to keep the term of the dy dx on the left, subtract the 2xy squared over to the right. So it would give me -2xy squared over on the right side. Just putting these in alphabetical order. Put the constant first, then the x, then the y squared. Make sure when you subtract it over that you realize it becomes negative. So let's call this 2x squared y dy dx. dy over dx. Now let's divide by 2x squared y on both sides. This will cancel. So dy over dx, which represents your derivative, which is the slope of the tangent line, equals, and let's reduce. These two 2's will cancel. This x will cancel one of these x's. This y will cancel one of these y's. So you end up with negative y over x. Right? That x cancels that x, so you end up with an x in the denominator. That y cancels one of these, you end up with a y in the numerator. There's your derivative. So we can use that derivative to give us the slope of the tangent line, because the derivative is the slope of the tangent line. So if you put your opposite of your y coordinate over your x coordinate, so the opposite of y would be -3 over -1, which comes out to 3. So now we can use this point-slope form of a linear equation to write the equation of that tangent line. So we'll go y minus this y coordinate of 3 equals our tangent line slope of 3 from right here, times x minus x of 1, which is -1. Of course, minusing a -1 can be changed to plus a +1. We can distribute the 3 through. So we have 3x plus 3 on the right side. Add 3 to both sides. Y equals 3x plus 6 would be our equation of our tangent line. This line is tangent to this curve at the point -1, 3. Now to get your normal line, you're going to use the same equation, except you're going to take your tangent line slope, and since we know normal lines are perpendicular to tangent lines, we're going to do the opposite reciprocal of 3, which would be -1/3 times x plus 1. Distribute the -1/3. That gives us -1/3 x minus 1/3. Add 3 to both sides. That gives us y equals -1/3 x. If we add 3 to -1/3, we're going to get plus 2 2/3.